Hey guys, so today we're learning about irrational numbers. This will be needed for your Australian Year 8 maths curriculum. And if you can recognize irrational numbers by the end of this video, then you'll be on your way to getting an A. But today we're not just going to be able to recognize them, we're going to understand a little bit about irrational numbers as well. This video will be broken up into 3 parts. First, we'll be going over what rational numbers are, then we'll be going over irrational numbers, and then finally, we'll do some examples before recapping. So rational numbers fit into number theory like this here, but you don't really need to know that. But for fun, we're going to see how you would represent rational numbers. Rational numbers can be represented by m over n, where m is any integer, so any whole number, can be negative, can be positive, and n is any whole number that you can think of. And using this, you can represent any number except for irrational numbers. So your rational numbers, however, would look like 8, 4, 7 over 10, 0.335, anything, right? If you can represent it like this, then it's a rational number. However, irrational numbers like pi, square root of 2, or the golden ratio, or Euler's number, there's so many of them, those are irrational numbers. And now let's try to understand why those are irrational numbers. For example, let's take pi. Now if you know anything about pi, you know that it's the diameter of the circle. So from here to here, and how many times that would fit around the perimeter of our circle. Just like this, and it's a little bit over 3. It's like 3.14, and 0.14, it's actually an infinite amount of decimals. Now, a rational number can be represented by an infinite amount of decimals. Say, for example, 1 over 3. That can be equal to 0.3 all the way, but we just put a dot over the top to represent that that's recurring. But because we can represent it as a fraction, it's not an irrational number. Now, however, pi, the amount of times the diameter fits around the circumference of a circle, that cannot be represented with a fraction, unfortunately. You can get close, there's great approximations, but you really can't. But pi, we use it everywhere. It's seen in so many things. How can we have an irrational number that doesn't make sense, but we put it in things? Well, it's because it's a really beautiful number. It occurs naturally, and it's needed in all sorts of things in engineering everywhere. Now, it's not just pi that's an irrational number. Let's go over root 2. So the square root of 2, that looks pretty simple. It's roughly 1.41, but this used to be so controversial that someone got executed over it. Now, I'm not sure how historically accurate this is, but do you remember Pythagoras, the long side of a right-angled triangle? Well, the guy who invented that, his name was Pythagoras, and he believed that all numbers were rational, or they could be represented by that m over n that we saw before. And it might be folklore, but it's said that one of his students actually proved to him that the square root of 2 was irrational, proving that they were irrational numbers. And he was so outraged by this that he killed his student. Now today we know that square root of 2 is irrational because we can't represent it as that m over n. We also have numbers like e, which is Euler's number. Now I could spend a whole video explaining what this e actually means, but just know it's roughly 2.7 with an infinite amount of decimals that you can't make rhyme or reason of. Now let's try some examples here of recognizing irrational and rational numbers. Let's start with this first one here, 0.5, and now it has a dot on top here, which means that 5 goes forever, it's repeating, so it's 0.55555 all the way to infinity. Now, is that an irrational or a rational number? Well, it's a rational number because we have a way to represent it. It can likely be represented by m over n, where those are 2 different whole numbers. But just know for now that if we can represent it with a dot on top or a line like this, it's likely rational. So 0.5 recurring, that's the name for when the decimal goes infinitely because of this dot on top. Now what about pi? Is that a rational or an irrational number? it's an irrational number because, as we talked about before, its decimal goes forever and there's no rhyme or reason. You can't really figure out a way that it repeats, or it's kind of random as far as we know. Now, what about 3/5? Well, that's represented in that m/n fashion. So that is a rational number. Now, what about this down here, 7.87, 87 recurring? Well, that's another example of a recurring number, and we know that those are actually rational. So, rational number. Let's try some more. So here we have 4 more numbers. Now, our first one, square root of 25. If you can recognize that, square root of 25 is actually equal to 5. That's pretty simple. That's going to be a rational number. How about the square root of 2? Well, as we talked about before, someone might have been killed over the proof that this is actually irrational. In later grades, you'll get to prove why it's irrational. It's a very confusing topic, but I'll probably make a video on it later. So it's irrational. What about e? Is that just a variable? No, e is not a variable. E is Euler's number. It's roughly 2.7 with an infinite amount of decimals that don't give any rhyme or reason. So it's kind of like pi. This is another irrational number, and you'll just have to memorize that this one's irrational. And what about 12 times pi? Well, we know pi is irrational. 12 times pi, that 12 isn't going to fix the irrationality. The only thing that would fix this irrationality is if we divided pi by pi, because then it would be equal to 1. And 1's pretty rational. So this number is irrational. So let's recap now, guys. Rational numbers, they're numbers that can be represented by m/n, where those are both just a whole number or an integer. And it fits into number theory like this, where rational numbers and irrational numbers are separate from each other. And the irrational numbers that you should be able to recognize are the square root of 2, e, and pi. And if you can remember those 3, you should be on your way to getting an A. So if you learned anything in this video, please leave me a like. If you want to learn something new, leave a comment asking and I'll make a video about it. Otherwise, I do have a tutoring service. Visit my page and you can find the link to that there. Thanks for watching, guys.